Welcome back to the course on artificial intelligence. Last time we discussed the last topic on the search methods. So dear students, if you remember till now we have studied, initially we studied the introduction to the terms used in artificial intelligence and the types of environments for an example, and then we saw how to solve problem, and we studied how to create the trees and to search them. Now we focus in chapter 7, the knowledge representation. So this will be a different one from the previous, and we will see what happens over here. So till now, so this chapter it will be about representation of knowledge and the reasoning that is done on the knowledge. So till now we have seen that AI it is used for managing complexity. So complex systems, there are systems which have millions of states that the AI can deal with, and those states it will try to find out the best possible answer. Okay, so we saw in these initial chapters how to create a tree and then use the techniques to solve those trees for a particular goal. Another thing which we haven't seen yet is that AI is also used to manage uncertainty. You have seen somewhere, it was also somewhere in your exams, that AI is used for uncertainty management. Uncertainty means not, you can say it is like not clear or not predictable. That would be the best word. Yeah, not unpredictable. Okay. So, if you remember at that time we discussed that the search methods that we can use, those search methods can only be used for the systems, for the environments which are fully observable and which are static and which are not stochastic, they are deterministic. Okay, so searching the methods that you have studied till now, they cannot be used if you are not sure about the input that is coming from the sensors. Now this is a big problem because practical life, almost all or most of the systems, there you are not sure about the input that is coming. Just imagine if there is a robot car that is moving, or there is a self-driving car. When this car comes on the road, there is no guarantee for anything that will happen. There is no guarantee that another car that is moving on the side, it may come in the path of this car. Or there is no guarantee that there is a person, a pedestrian standing on the road. He may jump into the road. He may come in front of the car. There is always a probability associated with any event. Maybe that probability is very, very low, 0.01%, but still there is probability. So practically, this thing we have not touched over here in this course till now, is that AI has a big role to deal with uncertainty or doubtful situations. So in that case, where there is doubt, a big area of AI is over there, which is a very, very vast field, and it's a really difficult one, difficult part of AI. It is the use of probability. So all of you have taken this typical course in probability and statistics. So the probability part that is used a lot over here in AI, and maybe in the future somewhere you will see like the Bayes rule or the Bayes theorem. That is a very, very important basics used in the AI for resolving uncertain situations. Okay, so remember the techniques, the base point is the techniques that you have studied till now, the search methods. They are not so much helpful when you are dealing with situations where there is uncertainty. So search, it can discover sequence of actions to solve the problems, but it is for those problems where you have a static environment and deterministic environment. Probability we use for uncertainty. So this is till now what we have seen. So probability we haven't touched over here. And overall AI in the present scenario, if you look in today's world, so now from this course at least you know that AI is not something new. This thing, the word was coined in 1956, a long time ago, almost at the same time when the computers were created first. So it's a quite old field, but it was mostly used on the theoretical fronts and on the experimental fronts. It is now in the past 15, 20 or 25 years where it has got much more practical application and much more you can say inclusion into our daily lives. So many new products are coming by the passing time that use AI. Maybe we know or using it for our well-being and for our comfort. So what AI is doing in this time till now, AI is pushing against the complexity in three directions. Pushing against complexity means that it is improving in these directions. So what are these directions? It is trying to improve, for example, the agent design. So there is a lot of work done for the agents. There are different types of agents. If you remember from your chapter number 1, over there you saw the agent, intelligent agent. Basically, it's any system that receives the inputs through the sensors and it provides some output. So there is for example, a sensor for input, and then it provides some output with the help of actuators. So actuator can be a motor, or it can be a screen, LCD screen, or it can be a light bulb. Okay, anything. And what intelligent agent do is that it will have some sort of memory and other important things, the other complex code that can analyze the input based on historical record, and then it will make some decision, the output, which will look intelligent, which will look a decision which is not random and it has some important meaning. Okay. So this type of agents, so this intelligent agent, I can write it IA for example. So this intelligent agent, there are two types of agents you can say are being used, and it is being practiced how to use the artificial intelligence algorithms in such systems. One of such systems is called normally the reflex based systems, and the others are called goal-based systems. Now, what is the difference? Goal-based and reflex. Now listen carefully. Reflex is basically, if you go in and search in the dictionary, reflex is some sort of action. So in plain English, other than the sciences, in plain English, reflex is some sort of action which has no intention. The simplest example I can give you for reflex action is, for example, you are in the kitchen and you are working, and there is something on the cooker, on the cooking range. There is some sort of some bowl or some utensil is on the cooking range, and you are heating water, for example, and you are looking somewhere else and you don't see, and suddenly your hand it touches that hot bowl. Okay, your hand just touches the hot bowl. What will happen? Yes, first thing that will happen, you are not looking at the bowl. Okay, first thing that happen is that without your looking, without your brain processing something, suddenly instantly your hand will go back. quickly it will retreat your hand, take it back. So this type of action is called reflex action, such an action where you don't think, you don't process the information. Another example, you are walking and or you are running and suddenly you stumble upon something, there is some stone or something, and you are going to fall down. And if you are going to fall down, suddenly your hands will automatically come in front of you. So your hands will touch the surface first, and your face or mouth, it will be the last, it will come after your hands. So why it happens like this? This is a reflex action of the body. It automatically does something that does not have to do anything with brain and with processing. So these are called reflex actions. Now what is a reflex-based system or reflex-based agent? Reflex-based agents are those agents where you provide an input and it will give you an output with a minimum delay. Okay, so practically we cannot say that like human brain there is some input and it will provide output without thinking. No, practically from a software point of view, when input comes, the system agent will process it and produce some output. So there will be a processing. There must be some sort of processing that will come from the reflex agent. Okay. So, but that processing is so small time that we can just say that it's ignorable. Okay. So reflex agents, what is the example? So you will ask me what's the example for such system, where we can have it. So these are the systems that work very quickly. A simple example for such a system can be in everyone's home. You have got these calculators. Okay, so for example on the calculator you press 2, so it quickly comes on the screen, 2, no delay. You press 2 plus 3 and you press equal to instantly, and if you try to measure even in milliseconds, it will be hard to trace that it gives you the answer which is very quick in milliseconds or even less than that. So this is an example of a reflex system, and calculator is an example because calculator is a very simple device. Hardly there is any, you can say, any thinking or any software or computation part. Okay, but these reflex systems are not limited for simple things. There are some other areas where reflex systems are used. For example, reflex systems are a lot much used in avionics. Okay, the aeroplane softwares. Similarly, all or most of the devices used in military, the software and the systems, the agents that are used in, for example, missiles, and also another important area is nuclear control systems. So they are mostly reflex systems. Why, you will ask me, why they use such system? Why not another type of system? So let me give you the contrary example. What is the other system? Goal-based system. They are the ones that normally will take more time, and they are oriented on the goal, and they don't care too much about the time. Time is important, but they don't care too much. So the example is that some input comes and they will process it and they will give you the output, but definitely they care about time, but time is not the utmost priority. So the example can be, for example, your a normal operating system, OS. So either it's Windows or a more sophisticated one, for example, in your mobile phones, iOS, Android. Okay, so all these systems, they are mostly goal-based agents where they do care about the time, but the time is not so important thing that can cause failures. So over here time is important, time is critical, but compared to the reflex systems, mostly in the other applications, I'm not talking about the calculator, but the other applications, for example in avionics, airplanes, nuclear control systems, over there the systems normally, I don't know, I explained in some other course also, that in such systems normally the correct answer should have two types of correctnesses. So it should be why it's happening like this. So it should be logically correct and it should be temporally correct. Two types of correctnesses are involved. Answer, for example, 2 plus 3, it should be 5. Yes, that's the logical correctness. But what is temporal correctness? The answer that is coming out, it should have some sort of deadline that it meets. For example, answer must come within 2 milliseconds. Okay. So if the answer comes 5, which is correct, but it is coming after 5 milliseconds, or it comes after 3 milliseconds, which is more than the deadline, then that answer is considered wrong. It's not valid. So there are many, then they have got some types for that. Sometimes some of the deadlines, they are soft deadlines, where answer coming late, it is acceptable with big penalty, with big fine. But there is another type which is called hard deadline, where answer coming late, that means wrong. We don't accept. These things are required for on the nature of the system. In the aeroplane, can the system afford, for example, if some input comes and the processor or the computing device, that there it takes time. So it takes time to give the output. Time is not over there available. It's a luxury, you cannot afford it. So such systems have mechanisms, the software that are created, that is a whole class of software, where they calculate, and they have special types of software. So you can explore if you are interested more. Normally they are called RTOS, real-time operating systems. So these are special types of operating systems that are created. They have certifications, they have licenses that give the guarantee that the application is running on this operating system. They will never hang, never crash, and never violate their deadlines. All this that I'm speaking, these are for complex systems. Definitely in your normal average calculator, there is no such operating system. But in general, it is so simple that it gives you answer very quickly. Okay. Whereas on the other side, goal-based systems, they have got their own operating systems, but these operating systems, they try to do the best, but they don't give you any guarantee. So this is the area where the AI is working, that how the AI algorithms, they can be exploited in those reflex systems and also in those goal-based systems. Clear? I hope this is a good discussion. It gives the idea clearly. Another area where the AI is trying to improve the things, it is the environment complexity, how to deal with it. So this is what we have not touched much in this course over here till now. That environment, we have seen at the start 6 types of environments, and we saw that it can be, for example, fully observable or partially observable or not observable, and then environment can have stochastic behavior, or it's deterministic. Many things can occur. So a lot of work is being done, and it is still happening, maybe on the theoretical side in the research or practically, where they are trying to deal and they are trying to introduce the AI on new types of environments. So I gave you the example, all the search methods we saw previously in the last chapters, they are mostly for fully observable static, deterministic, and fully known environments. Okay, but work is being done on other areas. So I gave you example that stochastic environments where there is uncertainty, there is a lot use of probability, the concepts from probability. So this is another area where AI is pushing against the complexity. And the last one is the model representation. So model representation means that now model representation is that what you will see in this chapter over here. So we focused over here that what type of intelligent agent we have, either it's reflex based or goal based, and what type of environment is on the outside. So let's say I mention the environment like this, the things that are coming from the outside. Okay, now the third thing is that when you have enough data with you, enough information that is coming from the outside, there is one more thing, how you should represent this information. Why is it important? Because remember, in the last chapters you saw many times that AI, it can be dealing, an AI system, it can be dealing with millions of states. So just imagine millions of states, how you will represent them in your computer, how you will save them. Okay, so that is another question, how to represent the model, how to represent the one single state or the whole state space, all possibilities, how they will be represented, how you will deal with them, how they can be used. So that is another area where we are still working, we are improving how to use them. So model representation means the world representation or the whole state space, how you represent when system is complex. So for bigger problems, how it will be done. So these are the three areas where AI is, and the latest in the AI, state of the art for AI, it's improving and it's working. So in general, when we discuss about the knowledge representation, remember intelligent agents, generally the system that we saw in the previous screen, if you remember, that we have done discussed in the first chapter, any intelligent agent, so it has got four important things. One is the input. Input comes from the environment. One is the output that you use to change the environment. And there are two more things that happen that we will discuss over here. So typically, any intelligent agent should have some sort of perceiving. Perceive means to feel. So if feeling is done with the help of sensors, or it is just like to acquire some information from the environment. So this we will not discuss over here. It's already not focus of our discussion here. And the last one is the output. That is you can say the acting. So acting is basically you choose what you want to do and you carry it out. So you have some aim or a goal and you perform it with the help of some actuators. So these are two things we will not be discussing over here. Our focus in this chapter over here is the other two things that an intelligent agent will have. That is how to represent the knowledge that it has obtained from the environment, from the outside. And then second thing is, based on this knowledge, can we do some sort of reasoning on this knowledge? Okay, some discussions, if we can do some sort of reasoning, is like some intelligent questioning or retrospect on this knowledge. So you represent the knowledge. What it means is you represent your understanding of the world, how the world looks like, the outside world, the environment looks like. So what type of input you are getting from the outside. If it is the game of the chess, what is the position of all the pieces of the chess board? So that is your input, and that you will use inside to create a representation of the chessboard, the environment, the world. You will try to make a representation inside in the system. And once you have got this representation, second thing is, just like humans, they think. So what is thinking? Thinking is basically to use the information to produce something new information. Okay. So if you remember somewhere in another course, I think maybe related to human computer interaction, we saw over there that reasoning, over there we saw it is basically you take an information and you try to deduce, or so there was deduction, abduction and induction, and we saw that you have some given information and you try to produce a new information that from that one. So reasoning, what it does is that it infers the implication of what it knows and what are the choices it has, and try to produce some new information. So from the given knowledge, try to produce some new thing or some new information. So representation of the knowledge and the reasoning process, these are very, very important. They are the central to the entire field of AI. Okay, because remember, the other two steps are very easy. They are not only related to intelligent agent. So getting an input and producing some output, this is not only for intelligent agent, it is for any type of agent. It's a common study in the field of embedded systems, that how you get the input, how you produce the output. The important thing is that how you are going to use that information, how you are going to store that information. That is what is the important concept, very important for the use of entire field of AI. Okay. So out of these four things for related to intelligent agent, we will be focusing in these two areas over here in the next chapters. Clear? So the objective over here, what we want to do is that we will try to formalize our knowledge about the world so far, what we know, and we want to make it formal, the knowledge that we have already. Formal means it should have some structure. Okay, so formal comes in, for example, you have a casual dress or a formal dress. Casual dress is, for example, the dress I wear when I am, for example, at home. I don't care, I don't want to meet anyone. That is casual dress. When I go outside home, then I have to wear some sort of formal dress. So formal means some according to some rules. Okay. So similarly, our knowledge, we have to formalize it. It should have some structure. It should follow some rules. Why it should have structure? Because if it has some structure, then it can help us to produce newer information. So if the knowledge has structure, we can use it to reason. Okay, we can make some arguments on this given information. Okay, so if it is the chessboard, the knowledge that is represented in the form of the positions of the chess pieces on the board, I can use that knowledge to reason. For example, what can I do next? And based on that, we can do some sound inference. Inference means to produce new information. New information you produce. So for example, inference is basically infer. It comes from infer. And infer means to produce something newer, some newer knowledge from your existing knowledge. It has almost the same meaning you have seen earlier related to reasoning. And also, when you have a formal way of organizing the knowledge, you can prove a lot of things. Okay, the data is with you. You can prove the things that two variables, for example, A is equal to B, and somewhere else you saw B is equal to C. Then you can say that A is equal to C, because indirectly they are both equal to B, so that means they are both equal to each other. And hence this formal representation of knowledge, it will help you to plan actions. You can make a plan for your future, what to do next. Okay, so what you want to do next, that you can plan, and it can in general help you to understand and explain the things. So always when you are making reasoning about the things, you are trying to infer the things, it means that you understand it quite well. Only then, if you know if you the knowledge that exists with you, if you understand it very well, then you can use it to produce something new. Some of these points I feel it will not be clear, some of them, okay, or maybe all of them. It will become more clear when we move to the example. It will be perfectly clear when we go over there. So we will see an example which is related to, which is called the Wumpus world. Okay. So in this chapter, what is the objective? In this chapter and in the subsequent chapters, we will see that we want the knowledge representation and the reasoning, and what we want to do is the form of representation of the world. That is one of the objectives of this chapter, and from this knowledge representation we use the process of inference to derive new representation about the world. Okay, so we will see now. For now, just think that inference is something. We will see what it is, how it produces new information, and from this new representation we try to deduce or conclude something new what we want to do. All of these definitions will be more clear when we see the example of Wumpus. Okay, so I will come back when we have discussed the example. So some of the definitions before we go next. In your system, always, so if you have an intelligent agent, okay, so intelligent agent, always it will have some sort of information inside the system. Okay, so remember, information is stored inside the memory. How it is stored, that will come in the next chapter. Over there I will explain it to you how we store information in the memory. For now, just imagine it, that there is some sort of mechanism that in the memory I store this much information. Okay, so this information is stored in the memory. The information that is already existing in the memory, okay, that information we normally call it knowledge. This one, okay, that is the one we call it knowledge base. So you can say this is the knowledge that already exists. It is the basic knowledge that the system has. Then and how the knowledge base is created, that's another question. How it is created? Basically, knowledge base is nothing but collection of sentences. So it is a set of sentences. It will have a long line of code, long line of sentences. Each sentence, it represents one information. Okay, so for example, in your system, I give you a very bad example. Maybe just imagine for now you have got some variables A, B, C, D. Okay, these variables, they are integers and they store some numbers. So these sentences related to the knowledge base, they can be some statements about those variables. Okay, so you have got, for example, these variables A, B, C, D. These sentences related to the knowledge base, they can be statements. For example, A is greater than B. That's one sentence. This sentence is showing some sort of fact or relation between the two variables. Okay. Another one, it can be related to, for example, some constant. For example, B is less than 100. So these are some of the these sentences, they define some sort of relation that will always be true. It can never be false. That's important thing for these sentences. Sentences that are part of the knowledge base, they can never be false. Okay. Okay. Remember, this structure of knowledge base, it is same as what our human memory works on. So in the human memory also, when a child is born, so a new baby born, when he or she starts, for example, crawling, in the whole house, the baby is moving and is learning and is trying to get information. That's the learning stage. So you see at that time the baby, it takes anything, whatever it finds, and tries to put it in his mouth. Why? Because it's trying to know about that thing. So for example, it does this thing, even if it's a pen, it's trying to know, can he chew it? What is the taste of this thing? What is the smell of this thing? All these things it wants to know. So slowly he starts to gather some sort of knowledge base. So knowledge base will be established, then it is basically made up of sentences, or you can say hundreds or thousands or even millions of sentences. What are these sentences? We all have these sentences in our mind. For example, sun or sunlight, normally it is very, very hot. Or if it is strong sunlight, it will burn the skin. That's a knowledge, that's a rule. So that is a sentence. So similarly, there can be sentences in the artificial intelligence related to our knowledge. We will have some sort of knowledge base, which is the collection of such sentences. I hope I am clear. Very important point. Pause it over here and try to think over it. If some sentences or words are not clear, search them individually on the internet and then think over it. And you can always come to the group and ask. And there is one more important source. Go to this book. It has got a wonderful explanation. So go over there and see over there what they explain about these topics. So how these sentences are written? So each sentence is expressed in a language. So remember, always when we try to define something, it is associated with the language. So when we are speaking, for example, we now are speaking in English. You people are speaking together with each other. You people speak in Arabic, for example. Okay. Similarly, anything that has to be expressed, it is associated with the language. Okay. The language that I expressed over here for these variables, this was the language of mathematics, maths. Similarly, for this thing over here, when I want to express the knowledge, for this knowledge, we use the language, we call them knowledge. In general, there is no specific language with this name. In general, we call them knowledge representation languages. So two of these languages we will study. One will be in chapter number 8 and the other will be in chapter number 9. So we call them logic detail in chapter 8 and 9. So sentences that are part of the knowledge base, each sentence is written in knowledge representation language. And each sentence that you see over there in the knowledge base, it represents some sort of assertion about the world. Assertion is just like the fact. Like I gave you the fact, sunlight, it is hot and it burns. Okay, so that's a fact. There can be many other facts. For example, when it is raining, the ground becomes wet. Okay, when it is, for example, weekend, most of the shops are closed. So some of the facts, they will not be true. For example, they are true in one country, maybe they are not true in another country. Okay, so human brain can easily adjust. It can quickly update the rules. So these facts basically are basically these facts, we call them assertions. They define some assertions about the world that we are focusing on, or you can say this about the environment of the intelligent agent. So here you see these are also facts. For example, A is greater than B. It's a fact. Okay, but assertions that are represented over here, or the fact that is represented here, it should be always true. A and B always should have. Only then you will introduce this sentence, when always A and B have this relation. No matter what the value changes of A. So for example, A changes for example to 10. Then in that case B should always be less than 10. Because if B is not less than 10, then this assertion will fail. This sentence will become wrong. And AI knowledge base only contains sentences that are always correct. That's the basic definition of sentence. Sentence is always correct, never wrong. I don't know if you people worked on this thing or not, but in programming, for example in C or C++, it's a very common practice in programming that over there is a keyword that is used. It was called assert keyword. So what was the purpose of assert? Assert was used for debugging the code if there is some problem in the code. Okay. So for example, you want to create a small program that calculates the under root of a number x. Okay. So it calculates the value under root of x. For example, if x is equal to 4, it will give the answer 4 under root equal to 2, and so on. Now to make sure that, for example, you want to be sure that never your program will be crashing, there is no bug, and you know already that if x becomes negative, then the square root of negative number will give you it will crash the program, because negative number, the square root is not possible. So in that case you can say, for example, assert x is greater than equal to 0. So assert statements are used in some programming languages. They are very common, and what they do is that they try to ensure some sort of fact during the whole time of the simulation. So until the simulation is running, this assert statement is always working, and if the x value becomes less than 0, that will stop the program and it will return an error. It will tell you that there is problem with this value. So you will surely know that this error is coming because of the problem with the x value, not some other problem. So this was one of the use. I don't know if you have done it in your programming courses or not. So these were some of the ideas we saw over here. These are the definitions. So basically we saw knowledge base. Knowledge base is based on sentences, and the sentences, they are written in knowledge representation languages, which we will study in chapter 8 and 9. Okay. Another definition, it is about the inference, and we discussed earlier, also saw somewhere that inference is basically a process. Okay. So inference is a process to derive new sentences from the old one. So that is what I gave you the example earlier. So let me give you another. For example, you have variables and you have sentence A is greater than B, and there is some other sentence that says, for example, B is greater than C. Okay. And then there is another sentence, let me make it more complex, C is greater than 100. Okay. Now if the A, B and C, all of them are integers. Okay. If they all are integers, so when C is greater than 100, it means that the value of C can start from 101. Yes or no? Yes. So it can start from 101. 100 is not possible. That will make this sentence wrong. So C is 101. That means the minimum value that the B can have, it is 102. Yes or no? Because remember, I put the rule that A, B and C, they are all integers. Clear? So it is 102, and then based on this, the third sentence, now A, it can have the values starting from 103. So this is basically, you see, it is not, initially it was not obvious. From these three sentences, you cannot find it out directly that A has a value starting from 103. But this is basically now, it is inference that given these three basic information, these three sentences, you produce a new information. This new information that we produced, this is the process of inference that gives us this new information. So we use the old sentences to produce some new sentences. So remember, we produce new sentences, and those new sentences, they become part of the knowledge base. So over here, how many new sentences I produce? So remember, these sentences are always true. They can never be wrong. So based on these three sentences, I can add two new sentences in my data knowledge base. One is B is greater than 101 and A is greater than 102. Now these two sentences, they are created from the original three sentences based on inference. Inference must obey the primary requirements that the new sentences should follow logically from the previous ones. There should be some logic. You cannot do anything without any reason, without any logic, and you cannot do anything randomly. Okay? You cannot create a sentence yourself automatically that B is greater than 200. Why? Any reason? Why? Okay? So you cannot do such a thing without any reason. It is not allowed. So sentences, they must follow logically from the existing sentences. I hope it's clear. So these are the four definitions we saw over here. Very, very important. Pause the video, think on these concepts of knowledge base, sentences, knowledge representation language, and this inference. Okay. Two more things, not directly related, not very important at this stage here, but it is about the declarative and procedural approach for programming. Okay. Till now, if you remember, you people have studied programming in, for example, C++ and Java, and also in Python. All these programming languages that you have studied till now, they are called procedural programming language. Why we call them procedural? Because the desired behavior, it is encoded directly as a program. So we call them procedural because you write the code as a procedure, as a sequence. Okay, so you write, for example, if statement, and then you write some more lines, then there is a for statement, and the program, it runs in a sequence. Okay, so program runs in a sequence, and if the sequence, something is changed in the sequence, for example, for statement, it was coming after the if statement. If I change it and put it before if statement, that will change the meaning of the whole program. Okay, so this procedural approach, it is based on sequence. There is another type of programming approach which is not so clear to you, which is called the declarative programming approach. So I was thinking an example for this. So declarative programming approach is the one where It is an approach to system building that consists in expressing the knowledge of the environment in the form of sentences using some representation language. The main point is not this, the one they mention over here. The main point of the declarative language is that you define a command. So it can be a command, or they gave over here the name sentence. And each sentence, it is independent of each other. So, and there is no such thing as priority. Okay. So you have a sentence 1, you have a sentence 2. For example, in the last slide, you saw sentence is A greater than B, and another sentence is B greater than C. Now, if you change the sequence of these sentences, if B greater than C, you write it first, does it make difference? No, it makes no difference if you change the sequence of these sentences. Okay. Another example, I don't know if this example is good or not, but all of you have studied databases, and over there you studied SQL language. Remember SQL? Structured query language, which is used to retrieve or get data from the database. Now you write, for example, one select statement. Okay. Select static from something. You write another select statement. Now the thing is that you can think, and it's not perfectly like this, but I just wanted to give you an example, that those select statements, you can say that they are behaving as a declarative approach, because the order of those statements, that does not matter. You write the second one, you type it first, and the first one you type it later. It does not make any big difference. Okay, so that's the main difference. There are many programming languages which are declarative programming languages. Unfortunately, you don't study any of them. You don't study, I think, at least now I am sure you haven't studied yet. But declarative programming style is a different type of programming style, and where the order of the instructions does not matter. One typical example you can think of is, you just imagine the mathematical formulas. So in the mathematical formulas that you write or use in mathematics, the sequence of those formulas, that normally does not matter, unless if one of the formulas, unless there is one condition, one of the formula, it produces some output and you are using that output in the second equation. That is a special case, but that is something different. That makes it like a sequential. Normally, these sentences are written such that they are atomic, they are individual, they are independent, they don't depend on each other. Okay, so these were some of the definitions we saw. The last one over here we saw is this declarative programming approach and the procedural programming approach. So again, pause it and go through it, and the next thing that comes, so let me check about the timing. So I think let's take a small break, and I will come back for the example